Good morning, Tehmina Khan is here. In TKMaths is fun. In today's video, we will see the explanation of box and whisker plot with Outlier. And it is a part of the syllabus of A-level mathematics S1. And the topic name is basically descriptive statistics, representative of data. So in the previous videos, we have seen cumulative frequency, histogram, stem and leaf, combining set of data. I will make today this video, coding data is uploaded. And with respect to these, we are including all this wherever it is required. So let's begin. What is a box and whisker plot? So the important thing here is in the box and whisker plot, you need to have 5 pieces of information: median, quartiles. In quartiles, you need to have upper quartile and lower quartile, maximum and minimum values. And these are the values which are shown on the graph. So it is a visual summary of the distribution basically. So we will see the shape of the graph. How does it look like? So for example, in a survey, this information is given to you about the height of the girls in a particular year group. And you have to express it in the box and whisker plot. So you always draw a straight number line and it takes all the number which are required in the graph. For example, the minimum value is required is 144 and maximum is 181. So accordingly, you will draw your scale. These lines in between are not necessary. Yes, to some extent you have to show, but not very much inaccurate. These are important, right? After that, you are drawing this box, and I will teach you in a proper question how do you draw it. The width of this box is your choice. But what is important to note is that you are labeling, right? You are marking exactly. So you mention here, what is this? It is 141, you write it down here, or whatever it is, 144 in this case. So similarly, you highlight all the important points here. Now notice this is called whisker and this is called box. Through the box, whisker is not passing. So please make note of all these important points. Not necessary to draw it under the line, you can draw it over the line. But usually we don't draw on the line because then it is difficult to read and then this line passes through it. So it is drawn above the scale you are taking or below, right? Okay, so here I have taken a few types here. If you see, the whiskers are equal in length and these two boxes are equal. So this type of distribution is called normal distribution. No skewness in it. Skewness tells you the inclination of the probability, right? Whereas in this case, if you see, the whisker is longer here, the box is bigger here. So when it is this case, we call it positive skew. Now this is how you check, is it positive skew or negative skew? You know, this is your Q1, Q2, Q3. So if your difference of Q3 minus Q2 is bigger than the difference of Q2 minus Q1, then you say it is positively skewed. Do not just look at the length of the whisker and say this is a mostly misunderstood concept, that the students usually see which side the whisker is longer and they say it is positively skewed. If it is longer here, negatively skewed. Not necessarily. There are questions in which whisker is longer on one side, whereas the box is bigger on the other side. So you have to take care of these concepts to figure out it is positively skewed or negatively skewed. In this case, Q1, Q2, and Q3. So Q2 minus Q1 is bigger than Q3 minus Q2. So it is negatively skewed, right? So please remember this thing. Now, what are the tips to draw box and whisker plot? The scale must be linear and labeled, like I have shown you. Whiskers must not pass through the box. I just explained it to you. Height of the box is your choice. When comparing two or more box and whisker plots, choose the same height for the box in each plot, right? So I have taken here example where I am taking 2 box and whisker to do the comparison of the data. So let's see this example first of all. In this example, the data is given to you. It is not told to you what it is. You have to find out quartile, median, upper quartile, and lower quartile, and maximum minimum point. That I can see very easily from here because data is very small. The minimum value is 13, the maximum value is 25. And whenever we are finding out median, upper quartile, lower quartile, we arrange data in the ascending order. So here it is arranged for you. And minimum maximum values are given to you. Now, because this is a very simple data, I have shown on the front next page how to apply formula also to find out median, upper quartile, lower quartile. Otherwise, in this case, you can calculate also. Total data are 1, 2, 3, 4, 5, 6, 7, 8, right? So half of 8 is 4th and 5th place. So median will be 19 plus 19 divided by 2, which is 19. And if you see from here, the center of these four data is 15 and 17. So 15 plus 17 divided by 2 is 16. Here it is this. In this case, it is easy. But still, I have shown you here on this page how to apply formula to calculate it, right? Because every time it is not easy to write down the whole data in the ascending order and then pick up or calculate like this. So the formula, if you remember, is n plus 1. N is the total number of data. In this case, it is 8. If it is lower quartile, we multiply it by quarter. So 8 plus 1 is 9. 9 divided by 4 is 2.25. The data present at the second place and third place will help you to get your lower quartile. And if you remember in the last video also, I told you when we have even number of data, then we get two central values to calculate the median or lower quartile, upper quartile, right? So for the median, I will do n plus 1 divided by 2, which is 9 divided by 2 is 4.5. So again, at 4th and 5th place. Now notice 1, 2, 3, 4, 5, 6, 7, 8. So this is 4th place data. This is 5th place data. So if you have to calculate median, you will do 19 plus 19 divided by 2. In lower quartile, 2nd and 3rd place, 1 and 2. Oh, sorry, 2 and 3. So 15 plus 17 divided by 2. And then in the upper quartile, same n plus 1 divided by 4 into 3. 3/4 of n plus 1 basically. So data present as 6th and 7th place, which is 21, right? So this is also you calculate. I mean, this is basically you do to find out all these quartiles. Now, after that, how do you plot? You draw the line here, and the smallest is 13. So we are starting making it from 12. It is up till 25. So we have written till 28 here, 1 or 2 units more than what is required. And then you highlight all the points which you have figured out here. Minimum, maximum, lower quartile, upper quartile, and medium, right? So all these after drawing here, marking it, you should label and write here these points also, right? In your diagram, you will label it. After that, you make this box. Make sure whisker is not passing through it. I hope it is clear. We make box here, right? Like this. And then vertical line, not horizontal line passing through it. And then you label it as well. It is not done here, but you will label here minimum, maximum, points, Q1, Q2, Q3. All this you will label it properly. So what we have seen in the box and whisker plot, that it is illustrating the spread of distribution. At a glance, I can see from where to where data is, what is the range of it, and what is the shape of the distribution. So these all come in the advantages of the box and whisker plot, right? Now let's see an example in which we will have two box and whisker on the same scale, and how it is beneficial to get the information at a glance. Okay, so let's take an example here. The data is of two groups who are playing computer game, and it is about their reaction time, right? So this data is summarized here for you in terms of minimum, maximum, median, lower quartile, and upper quartile. So now you have to draw box and whisker for each. So here it is drawn here. The scale is taken here because scale is same for both. So we will see overall what is the minimum, which is 0.4, and overall what is the maximum, which is 1.9. So this is representing group 1 and this is representing group 2. Mostly in these type of question, it is asked and compare the reaction time or compare in context of situation or context, whatever is given to you, right? So your comment should be based on this. So if you look at this, what comes in your mind? Which group is better, group 1 or group 2? Because if somebody has less reaction time, he's better. If somebody take less time to finish the race, it is better. So it depends on the situation. Either more is representing a better result or less. If I'm talking about the student's marks, then of course more is better. So according to the situation, you will reply. In this case, definitely group 2 is better. Their reaction time is less. Their spread is less also. The spread is from 0.54 to 1.6, and it seems more consistent. Whereas if you see group 1, this is bigger. It is varying a lot. This side is longer, right? So this shows that group 2 is better reaction, has better reaction time, and they're more consistent compared to group 1. Let's see the comments written here. The median reaction time is 1 for both. So if you are commenting only in terms of median, then they look same, but actually they are not. Group 2 is smaller than for group 1 compared to range of time. Greater spread in group 1. So in this scenario, greater spread is not a good thing. When the data is close to each other, it shows consistency in the data. So this is why they are saying group 2 is a better group in this game. Okay, so overall, what we have seen so far in this video, that how to calculate positive skew, negative skew. And here it is shown in terms of cumulative frequency, in terms of box and whisker, in terms of histogram, that how you can comment on the skewness. And here I would like to say thank you to those YouTubers who make videos. I have taken it from one of the video. I like the idea. It was summarized very well. So thank you to the people who make it and facilitate the learning for everybody, right? So this is how you, now this is something important, lower quartile and upper quartile. I would like to talk about it in the next example, right? So just hold on for this idea. In next example, I will cover it. So lower quartile and upper quartile, sorry, outlier. If I use the word quartile, I'm so sorry. It is outlier. What is outlier basically? Outlier is a data which it is very low or very high and is affecting the result, right? And anything could be a reason for it. If we are doing, for example, some experiment, so maybe there is an error in it. If we are taking some reading, maybe the machine had a problem and it gave the wrong reading. So very high or very low value, which is affecting the result overall, is an outlier. And how do we decide in the data which values are considered outlier? So the technique is, when you do Q3 minus Q1. Now, if you remember, Q1 is lower quartile and Q3 is upper quartile, right? So when you do Q3 minus Q1, what do you get? If you remember, it is interquartile range. So when you multiply interquartile range by 1.5, whatever the answer you get, if that answer you add in, let me say answer is 8, for example, right? So in Q3, if I add this answer, whatever the value I will get, and if I subtract this answer from Q1, right? Q1 minus this answer. So if I subtract this answer from Q1, then whatever I get, if those two values are giving me boundary, anything outside it will be considered outlier. Okay? So let's see in the example, and I hope it will make more sense to you there. So for example, this data is given to you here. And first of all, you are just plotting it without showing outlier, without calculating outlier. You're just drawing box and whisker for this, right? So this is your low quartile, median, upper quartile, minimum value, and maximum value. So here is your box and whisker. Now you have to find out outlier and then plot the same graph. And you will learn how to plot outlier on the box and whisker. So what we are doing here, we are finding out Q3 minus Q1. Can you see Q3 minus Q1? 19 minus 12. 19 minus 12 is 7. Then you multiply 7 by 1.5, okay? And then you subtract from lower quartile. You get 1.5. Is there a value less than 1.5? Yes, this value. So this is my outlier on the lower side. I will How will I mark? I'll just show it to you. Okay, so again 19 minus 12, which is Q3 minus Q1, 7. I'll multiply it by 1.5 and then I will add in the upper quartile. I got 29.5. Is there any data bigger than 29.5? Can you see here? No. So let's draw now this graph. Sorry, this value is I missed it. I don't know why. So this is my outlier. These two are my outlier on the upper and lower side. So now if I have to draw box and whisker, keeping or showing outlier in the graph, how will I do it? This is how I will do it. These points 33 and 1, I will just mark like this. I have 33 here, right? This is 33 and this is 1. And why did I stop whisker here? Because I will see what is the next bigger value after 1 is 8. So at 8, my whisker will start. And here before 33, it was 26. So my whisker will end at 26, right? And the rest of the thing will remain same. So this is how you plot box and whisker when you have to show outlier on it. And in the exam, if the question comes, even if it is asked or not, show it, calculate it and show it outlier there. Now let's see the box and whisker plot advantages and disadvantages, because this is oftenly asked and you should also know when you are studying it. So number one, it is very easy to see the distribution just, by the, even at a glance you can see Q3 minus Q1 or Q2 minus you can easily see with the length of the box and with the help of the whisker also. But whisker can disguise you because of the outlier position. So do not depend on it. And disadvantage, it does not show frequency. We do not know actual data there because it is a summarized form of the data in 5 important points. So it also shows outlier. We can see the range, we can see the interquartile range, and we can compare two sets of data also very easily. So thank you very much for watching this video. Please press like and subscribe button and share it with your friends. And my next video will be on combining set of data and histogram. Take care. Allah Hafiz.